A little bit about my background is I've been a network engineer for over 3 decades. So if anyone wants to ask me any ArcNet questions or questions about coax or Vampire Tap Ethernet or Novell NetWare, always willing to share a beer and talk about that sort of stuff. A little bit about my history, though, is that all through those years, I got frustrated with how manual troubleshooting is. And that there's just too much of the, gee, we don't know what's wrong, and you have to tell the user that, and you have to tell management that. And it means that you have to go try and collect more information and try and find out what's going on. And it might be days, weeks, or months to actually be able to solve problems. And I figure that's not the right way to run a network. The right way to run a network is to have automation in place, that the right information is brought to bear in an automated fashion so that you can actually be pointed out, here is the root cause of that problem, so that you don't have to scramble about trying to guess as to what's going on. And so we figured that was missing from the market, and that's what we decided to build. So I'm going to be covering 4 areas. The first area is network operations. That's our core solution. We're then going to cover what we do for telecom, and then cover what we do for security, and then show what we're doing for work at home users. We have a new module called Remote View. So I'm going to move through these pretty quickly, and then we'll handle the questions at the end. So let's dive in. So many organizations, they have an existing monitoring system, which usually is you set up a single collection server, you set up and license a database. Maybe you have to set up a couple of remote collection servers because of scalability limitations. Then you go starting to configure it. And this configuration effort is typically a manual exercise where you tell it, here are the switches and routers I want to monitor. And then you figure, well, I want more information than just pinging these devices. So you go out and set up interesting interfaces, usually internet connections, WAN connections, trunk ports, those sorts of things. At this point, usually you run out of time, effort, or you run out of licensing, and you say, okay, we're done with network monitoring. We have to get on with our day job. Then what happens is a user comes up to you and says, hey, I had a problem. You say, okay, you check your monitoring solution, and the monitoring software says everything's healthy. What that is that's a disconnect, because it means that the user had a problem that your monitoring system simply isn't aware of. So this leaves you having to log into switches, log into routers, check interfaces, check error counters, check configuration, looking for that needle in a haystack as far as what caused the problem. Sadly, you can go through this exercise and still not find the problem, because you have to be looking when the problem's occurring to actually catch it. So you tell the user, well, maybe the next time it happens, we'll get a little bit closer. And that just leaves them frustrated. It leaves you frustrated, and your management team frustrated, because everyone knows that this problem isn't going to be solved the first time, the second time, or maybe even the 5th time. So this is where we decided to look at this and say there needs to be more automation brought to the picture. So here's what we're doing. So TotalView installs on a single virtual machine in your infrastructure, and we're going to go out, find, and collect information from every device in the infrastructure, as well as every interface. If you think about it, you're held responsible by your user community and your management team to know what's going on throughout the entire infrastructure, and we figure we're going to make sure that your visibility matches your responsibility. The second thing we figured is that your equipment is incredibly smart. There's all sorts of error counters, all sorts of things trapped up inside each one of those devices. So we're going to go automatically collect it. No matter what make or model or manufacturer this equipment is, we're going to get your performance, your configuration, 19 different interface error counters, all the QoS, CDP, LLDP, PoE, everything that's connected. We then pull that information back and put it through a heuristics engine. The heuristics engine identifies what the problem is, because it analyzes all of that information to say, you have a cabling fault, you have a microburst link flood, you have a duplex mismatch, you have a QoS misconfiguration. So that way, we're able to tell you all of this information within the first hour of deployment. And something to recognize is that all of these problems wouldn't be found by your other monitoring software. So we end up disclosing all sorts of hidden things that are broken in your environment. because we figure you should know everything your network equipment knows. So this core package has everything needed to run a perfectly healthy network, including diagramming, port mapping, server monitoring, event correlation, IPAM, inventory, a MIB browser, and configuration management and automation. So this is the core package, figuring that you need anything you need to solve a network problem is automatically built in, and you're going to be pointed out, here's what's broken in that environment so that you can rapidly fix the problems. Now, our first module focuses on telecom. So this is an optional module you can purchase if you want to focus on this area. But what it allows for is, the first thing is you can do call path mapping. Let's say it's quitting time and you're packing your bags to leave, and a user says, hey, I had a call quality problem at 2:30 between my phone and the phone in the other office. Okay, put in those 2 IP addresses, and we're going to path map the network, showing you every link, every switch, every router used to connect those 2 phones. And we're going to show you the health of those over time. That way you can look at it and say, well, around 2:30, this one edge router was dropping 12% of its packets out of the high priority queue. That would definitely create a problem. And then on the far end side, the station cord had a cabling fault. That would also create a problem. But you now have the root cause of what caused that call to be bad, and can say, let's get some more queue depth on this edge router, and let's end up getting a new station cord out to the far end phone. Thus, you get the root cause of the problem solved.
A quick question.
Sure.
Let's say you don't know the other end. You only know one IP address. You know that it's John's phone. Okay, so now you need to go look up IP addresses based on who it is, phone number, et cetera. How does that work?
So you can look that up either through CDR or through whatever phone system you're using. This doesn't have to be phone to phone. This can be PC to server, video conference unit to video conference unit. So you'd get that through your CDR of your PBX, or you'd end up looking at that information on your gateway. So this way you can root cause resolve what happened between any 2 IP addresses at any point in time, because you're focused on, here are the errors and problems that happened along that path at that time.
Okay, so let's take the other scenario. So John complains about it, says it was at 2 o'clock, but he doesn't remember who the other party was, or it was an external one.
You'd look that up in your CDR record, find out here's the call that was made, and then can put those IP addresses in. So a lot of systems, a lot of phone systems will have that CDR ability. The problem that is missing is they'll say, gee, I can see a bad phone call. I can see another bad phone call. I can see a bunch of bad phone calls. How do you research the network with enough granularity to find out where did the problem happen and why at that point in time? And that's what we're solving. Make sense?
So does it also allow me to take a look at, does it monitor CDR information or CMR, the call maintenance records as well, to say, gosh, John did have a phone call. It was at 2:15, not 2 o'clock, and it was a bad call.
So we're not looking at CDR records or CMR records. Really what we found is there are companies that are going bankrupt because there's so many companies out there that do that, look at CDR records. And so CDR is kind of basic. There's a lot of companies that do that. The problem is that for the past even 8 years is every one of those telecom teams says, I see a bad phone call, but I have no ability to resolve it. The network team has no ability to resolve it. So we're going to be the first company that says, this is how you resolve those problems with that data. And in fact, actually, a lot of PBX manufacturers, as well as Unified Communications, you can just log into their own tools and look up that information. So that's pretty readily available, since that's been something that the industry has built for quite some time, is the ability to look at those CDR records and say, who was this from, who was it to, and what was the call quality? It's the ability to resolve the problem has been missing. Okay. Next is we have a license unlimited call simulator. The call simulator can simulate VoIP calls across your LAN, across your WAN, across the far end LAN, all the way endpoint to endpoint. That way you can find out, where do we see latency, jitter, loss, out of order, or loss of DSCP tag, so that you can determine very quickly to narrow down, hey, we're losing packets across the MPLS link, and we can prove it because it's only when we cross that link is when we're losing those packets. Or we're getting out of order through the MPLS, or we're getting loss of DSCP once we leave the local switch.
Tim, real quick on that one.
Sure.
Can you actually leverage IPSLA on Cisco routers?
So we don't use IPSLA. What we've kind of found is that IPSLA requires an all Cisco network, and not everybody is all Cisco. Also, IPSLA puts a tax on the routers, and that CPU tax is something that not a lot of folks actually want to enable. Additionally, it's not truly end-to-end. IPSLA is great for testing across an MPLS link, but you're not getting end-to-end perspectives on that. So we kind of see IPSLA as it's not the best way to do those sorts of tests. The best way is to do actual end-to-end testing like what we have with an active call simulator. Other capabilities, we have QVision, which looks into Cisco QoS queues to show how they're configured and how they're performing. We do full SIP trunk monitoring and troubleshooting, and so we can troubleshoot that outside the network perspective. We can locate your phones and trigger alerts if phones are moved. We also have MOS score monitoring and alerting, and can track all of the PoE so that we can make sure there's enough power to support all of your phone devices. So everything needed to run a perfectly healthy network for voice. The next area we're going to cover is our security operations module. So first thing we have here is SOAR. So if you have a SIM or an IDS that says, hey, we found suspicious activity on an IP address, most SOC teams have to pull open their playbook and say, okay, there's 17 steps we need to go through. It's going to take about 30 minutes worth of research, and I have to use 8 different tools to be able to do this research. So it's very painful to do the research to find out, is this a false positive or is this an actual bad actor? We're going to simplify this because all inside of our tool, because we have so much knowledge of the network, we're going to be able to tell you, here is where that device is plugged in. It's connected to the Finance 2 switch, interface 12, VLAN 110. By the way, it's a Dell computer running Windows 10. We're also going to be able to tell you, here's who's logged in and what their rights and capabilities are. We're going to tell you what's running on that box. We're going to tell you who it's communicating with and how, and then we're going to give you an overall risk profile and allow you to quarantine. Now, if you were presented with all of this information, all of these indications of compromise, I think every one of you within 30 seconds would be mashing that quarantine button to say, get this off my network. And that's really what our trick is. Instead of 30 minutes worth of research, it's now down to 30 seconds because all the information needed to render a decision is in front of you. The next thing is we have policy monitoring. If you have a high security database that should only be accessed by a set number of users, you put your firewall rules and ACLs in place to say nobody else should be accessing this database. But how do you know that those firewall rules and ACL rules are actually working correctly? If you put your policies into the TotalView server, it's going to monitor those communication policies so that if 3 months later this communication occurs, we're going to immediately trigger a policy violation alert. That way, you go into your ACLs and find out, what? Somebody put a permit all at the top? Okay, who did this? And we can also answer that question because we're monitoring configuration changes, and we can actually tell you who did this and when. Next is OS vulnerability detection. So for all of these switches, routers, and firewalls, we're synchronizing with NIST every 24 hours to determine what are the published vulnerabilities on these devices. That way, instead of having a separate tool that you have to do for scanning and fingerprinting and say, well, scanning is very painful, it ends up taking a really 48-hour period, it puts a burden on the network. No, that's not part of what we're going to do. We already know what these devices are, we're already talking to them, and we can do a very quick check with NIST to say, these are the devices that have published vulnerabilities. That way, you can spend your time remediating those vulnerabilities and upgrading the operating systems.
And do you also check whether they're configured with the particular configuration that's needed to expose those vulnerabilities?
So we do configuration management. So I'll say we're moving towards that direction, but we currently don't do an active check of that configuration. Next, one thing we understand better than any other product is your security footprint. because we know everything that is connected to your network, if you find that there's some strange new vulnerability published for AudioPhone 335s and you're wondering, don't we have some of these on the network, or did we decommission all of them? I don't know. Well, with one search, we're going to be able to tell you, yes, you still have 3 on the network, and here's where they are. That way, you can immediately mitigate that and say, let's lop these off the network, or maybe we upgrade them so that we know what's on our network and where it's connected. Additionally, we have new device detection. If some mystery new device pops into your network, within 5 minutes, we're going to be able to tell you, here's what it is.
Just hold on a second. I have a question regarding the vulnerabilities or security detection. You can detect only what you know. There's no behavioral mechanisms or something that you can see something is treating not so good or not as it should, but it's only a known vulnerability that you can find.
Correct. We're synchronizing with NIST,
Okay.
and NIST has the published vulnerability, so we're synchronizing those published vulnerabilities with what's on those devices. So we're not doing behavioral type of checking.
So the whole network can be infected already before you find something.
So there are certain things that we'll catch. We can catch man in the middle if there's a MAC address that's been spoofed, because we're checking ARP cache against DHCP. So there's certain things we still can find, but what I guess I will still say is I will agree with you is that we are not doing behavioral.
Okay, so when a computer is infected by by malware who is making cryptocurrencies or something like that, this is something you cannot see.
Depends upon how it acts.
Okay.
If it's quiet and it's just sitting there doing its cryptocurrencies, if it's communicating with inappropriate countries, then yeah, we can actually say, hey, there's communication here that should not be occurring.
Okay, but based on IP and known IPs and known things known.
Yeah.
Okay. Yeah. Thank you.
So when it comes to something like maybe a 0-day that hasn't been published yet, that's not the space that we'll be detecting things in with PathSolutions. Then.
Yeah, I'm going to say it depends. It depends upon the countries that it's communicating with. So let me continue on. I have one more slide I think that will help be appropriate for talking about some of that. Is so for new devices, we can detect a new device as soon as it's plugged in, within 5 minutes, I should say. What is it, where it's connected, who it talks to, and what they're doing. That way, if somebody plugs in some HVAC controller system, you're going to be aware of it, and you're going to say, gee, this Siemens controller has a default password on it. Let's get it off the network, go talk to the facilities guys and say, you need to make sure when this goes on the network, it does not have a default password. So we have geographic risk detection. So if there's communications outside of the country that you're in, or if it's going to a blacklisted country, you can trigger alerts on that can go back into your SIM. There's exposure monitoring if we see bad practices like unencrypted HTTP. So in talking about the behaviors, there are some behaviors that will expose themselves to us as an exposure. For example, if it's doing DNS spoofing, if it is using unencrypted HTTP, if it's using Telnet, for example. So if it's doing things that are bad practices in a secure environment, we're going to say that doesn't look right and be able to flag that. And that way it goes into your SIM as part of that complete picture of what's going on. So in one sense, I can't say that we're deep in the behavioral, but there are certain things that we can detect based upon how it is acting. So I'm going to say behavioral light. But I think really in a high security environment, you're going to definitely want something behavioral. But in order to respond to that, having our SOAR, having us be able to say, these are good policies you can put in place, these are good practices you can put in place, this is going to cover a base for a lot of folks where they say, I can't write 15 checks to 15 companies, yet we're going to cover a lot of those bases with the core solution because we know where everything's connected. We know who's talking to who.
Tim, a real quick question, just if you can hit one slide back. I didn't want to interrupt your flow on that one. But In terms of the mystery device, and you said you're doing correlation to sort of discover the device itself. Are you doing that for V4 and V6? I mean, are you grabbing V6 global unicast, you're grabbing link local addresses, maybe solicit node addresses and matching them up with V4 addresses so you actually know it's one host, not 4 hosts or 6 hosts or something else in terms of configuration, and can you actually track that?
So what we're doing is we're finding out that there is a new MAC address that we have never seen before on the network. And we look up the manufacturer and say, okay, this thing is Siemens. Who does this thing talk to? Where is it plugged in? What is it? So it's really answering those sorts of questions based upon the fact that we've never seen this MAC address before. Now, obviously, if you have a guest VLAN where you have people coming into your lobby and they're connecting to your guest, we can exclude all of that because, of course, all that stuff's just going to be new stuff that you've never seen before as people walk into your lobby. But for people who are on your network, we're going to be able to say this thing is new. There's a new virtual machine, for example. There's a new PC. These sorts of new devices, you need to make sure that they have the proper security protocols, that they're following the security policies that you've put in place.
Right, but I normally write my policies in V4 or V6 ACL. So am I actually getting the V4 and V6 information? Am I getting V6 information off the host? Did I get a global unicast address and I can actually see that host, got it via Slack or via DHCP V6, or what's this?
So your V6 question, I guess what I'll do is I'll go into a little bit about V6, is that we do support V6 for browsing into browsing into the TotalView server. We don't support V6 of collecting information off of switches and routers yet. What we've kind of found is we haven't had a lot of customer demand for that. I would love to see customer demand for that so that we could build it, but I'll admit to you is we can't build the things unless there's a tangible reason to do it yet. I do see that as our future. It's just that we're kind of waiting for that tidal wave to occur, and we haven't seen it because our customers haven't demanded it yet. Okay, so the Security Operations Manager, there's no separate software to install. This is just a license key change. So I think that's one of the things that makes our solution powerful, is that you deploy this and you can enable or disable whatever features necessary, and there's very little for you to do in terms of configuration or anything. It's just these features become available simply because we have the information already collected and analyzed.
This is Terry. Is it possible to edit the list of countries?
Yep.
So basically I can set up a fence around my organization then.
Exactly. So in one sense, I'll say is we have a lot of municipal governments that are our customers, and these municipal governments find that they're like, we should not have any communications going outside of the US. And it's very easy for them, is they just say, let's blacklist every other country. And so if any communication happens outside of the country, they're immediately given an alert. They can look at it, find out what it is. And I'll admit, most of the stuff they find is simple things like NTP is going to synchronize us off of a server in Tokyo. Okay, that probably shouldn't synchronize there, but there are NTP vulnerabilities, and you can eliminate that by changing all your NTP to saying, let's actually have our hierarchy done correctly, where we're synchronizing off of our own servers. Okay, remote worker troubleshooting. So we saw COVID as changing the dynamic of what IT is responsible for. In the past, if we can say just a year ago, is IT departments would say somebody's home network, we don't care. We don't support that. Whereas what has happened is there's been IT organizations that have been tasked with saying, well, we're not going to make you fully responsible for a home user, but you got to help them out because work can't happen otherwise. So there's a large group of folks that say, well, we got to try and help solve these problems because users just don't know. There are a class of folks who are working at home who typically C-level folks or maybe critical employees in critical spots where the organizations are saying, you must support these folks. You must actually get them a router, get them a firewall, put them on the corporate network, and you are now responsible for their home networks. Regardless, most of the organizations have to do something to help. And so we figured really what there was is a lack of information. So let's go through a sample scenario of how folks try and help users today. So if you have a CFO working from home and they have a poor quality Zoom team meeting, the first thing you do is you scope the problem out. So you have the internet component, you have the Zoom team cloud server component, you have the headquarters component, and then you have the user's home office. Inside their home office, they have some $19 firewall, they have some unknown brand of access point, and then they have their laptop. And problems can abound because you can have weak wireless signal strength, wireless channel contention in the neighborhood, firewall issues, ISP overload issues, split tunneling problems. Every one of these makes it really challenging to solve, because if you say, hey, let me help you out, let's schedule a meeting, and you find out, okay, it's going to be 2 days before you can get a meeting scheduled according to your calendars. You get the meeting scheduled and the user can't get into the meeting because their packet loss or latency is too high. Even if they do get into the meeting, they try and pass control over to you. You finally get control and you realize that the tools available to you are ping and traceroute. You're not going to solve the problem. So here's what we decided to do. You send the user a single agent and say, here, run this at your convenience. What it's going to do is perform a batch set of tests against every one of these elements, pull that information back according to the user's perspective, and then send this information back to the TotalView server. At that point, it's going to send out an email notification to the engineer to say, hey, the results are in. Just like a doctor who gets a notification that the patient's lab results are in, you get to sit down and say, let's review everything. Well, looks like their laptop is fine. The CPU is good, RAM is good. Their wireless signal strength is low. We can tell you, here's how to walk around your house and use the tool to do a signal strength mapping of your house to see, is it stronger on the first floor? Is it stronger on the second floor? Also, in your neighborhood, is this an apartment complex with a lot of density? Yeah, everyone's using wireless channel 3, but nobody's using wireless channel 6. If you switch to that, you're going to have a good time. And your firewall is adding about 20 milliseconds of latency.
I got a question for you.
Yep.
Can you correlate this with upstream devices? Like you have it on the laptop now. Can you, for example, provide it with the upstream switch, router, etc.?
We have tests that actually have all of that information so that we can determine, is the packet loss happening between the laptop and the firewall? Is it happening between the firewall and the ISP? So we can determine where is the latency, jitter, or loss occurring along that path to be able to say, this is your problem. That way you get down to a root cause answer.
Okay, thanks.
So we'll tell you what's going on with your firewall. We'll tell you what's going on with your ISP. If you're only getting 4.2 megs of upload and you've got a couple of kids doing schooling at home and a spouse that's also doing meetings, you're not going to have enough bandwidth. So we're able to tell all of this information in a fully automated fashion so that you as the engineer can spend just 2 or 3 minutes and look at all of these results and say, here are 5 things you can do to improve your environment at home. So here's a screenshot of a wireless signal strength test that I did, and you can see the RSSI signal strength towards the left side when I started this test is kind of yellow, and I started the test in my kitchen. But I picked up my laptop, and second by second, it showed green. It started to move to green as I walked into my living room. As I walked out the back door of my house, though, into the far corner of my yard, it quickly went to yellow, red, and then black as the signal degraded. So you're able to walk around and determine where is the signal strength strong and weak in your environment and know that, gee, I didn't realize that this one wall here must have a whole bunch of brick in it with some rebar because wireless is terrible when going through this one wall. So that's pretty much it as far as what we can cover in a network. And again, our whole trick here is automate the troubleshooting so that you're not having to say, well, to go try and collect information manually and try and put it together. We figure if we automatically collect the information, we put it together, we can lead you to solving the problem faster.
Hey, Tim, Chris here, got a question. What's the main data source for a lot of this stuff? Sounds like, probably use an SMP to look at, a lot of this, maybe some more advanced stuff like NetFlow data, maybe some agents and whatnot. Model-driven telemetry, maybe, I don't know, just kind of would love to hear where a lot of this data comes from.
Yep. So SNMP is our primary source, and then we enrich it with NetFlow information and syslog information. We also do have CLI information we can extract, SNMP traps if that's, so it's effectively the core is through NetFlow. The biggest enrichment is still, I'm sorry, the core is SNMP. The biggest enrichment is NetFlow, and then syslog will help add some more flavor as well. So it's kind of like if you have this giant pot of stuff, we're automating getting all of that SNMP out of those devices to say, here's what the devices know is broken, and then we can do correlation type of activities with that NetFlow and also syslog.
Tim, hey, this is Jeremy. I was wondering, can you talk a little bit more about your syslog correlation? Like, you know, because if we see like a whole bunch of different syslog messages from a whole bunch of different devices across our network, and, you know, as a network engineer, you know, in your brain, you're correlating these events and say, okay, I'm finding a root cause, but I have to piece together this BGP, you know, syslog, and this interface syslog, and this transceiver DOM, you know, syslog, all these kind of different syslogs happening across the network in the same time space. Do you guys do that kind of correlation?
So I'm going to say for syslog, no. In one sense, we're not going to reinvent, you know, something like Splunk. Splunk is going to analyze the syslog information. We're going to be analyzing all of the SNMP and NetFlow information. And so we can actually feed into Splunk with our data to be able to say, hey, we found that there's a cabling fault based upon the interpretation of how the device is configured, how the device is operating, what's going on. There is a cabling fault that we dropped 6% of the packets on this interface. We can feed that information up to Splunk so that Splunk has a more complete picture of what's going on. That way you can look and say, well, in Splunk, you're going to have all the logs, the syslog information that says, gee, these users had problems. These are the issues that occurred. And we're going to be able to say, yeah, it's due to a cabling issue in this one wiring closet. And at that point, you're going to say, well, who was in that wiring closet at that time? Well, Bob was adjusting fiber. Okay, Bob, you turned that fiber a little bit too tight and you caused all of this cascade of issues here, but we're going to be the one to feed that cabling fault issue up to Splunk to finish the enrichment of their data.
Yeah, but the Splunk, you know, is deficient in two areas, or any approach that requires an external log server. It doesn't do the correlation that I asked. And then it also requires, you know, the network engineer or somebody to write all these grok parsers to understand the various differences between all of the vendors and their syslog, you know, messages and formats. And as an enterprise customer, you know, I don't want to do that. Like I want to buy a product that understands, you know, I live in the network space. You know, it understands network ease, and it understands the relationships of these syslog messages and how they could form relationships for root cause analysis. So if I'm looking for a root cause analysis system, you know, I'm looking for this kind of feature set. And so even if it's not in the PathSolutions product today, is it something your other customers have been asking for? Is it something that might be on the roadmap, or is it just something so far out of purview for you guys, you just kind of want to push it off to, you know, roll your own with a log aggregator?
Okay, so a whole bunch of questions, and I think the way I'm going to answer that is, what we figure is we will solve the problem for the networking professional. And the point being is that we figure if we know more about all of the layer 1 in your entire infrastructure, we know more about all of the layer 2, all of the layer 3, and we start looking into prioritization, QoS, application, and layer 4 in the 7-layer model. We start moving up that stack. That means that for the networking folks who are saying, hey, we're responsible for everything up to layer 4, they're going to have everything they need pre-correlated in our solution. For the server folks that are going to say, gee, we're using Splunk to be able to analyze server slowdowns, cloud server slowdowns, those sorts of problems, they're going to be doing log analysis. In that point, it makes sense to have us partner, which we are signed up to be a partner of Splunk to be able to feed data into their solution. That means we're not going to go all the way up to the application layer. We're going to focus on what the networking folks need and be able to go deeper into the network, broader into the network, and do more automation in that area than saying, gee, we're going to go all the way up to the top of the stack. I see other companies as being stronger in that area. Therefore, you'd partner with those companies.
Just a quick question about kind of scale. Obviously, I'm sure it depends on the number of interfaces, in your environment, but how often do you pull and how quickly, how many pullers would you need, within kind of an average network?
So in general, you really only need one puller, and that's typically a single virtual machine. If you want multiple pullers, you can choose to do that. But I'll say is our scalability is actually pretty strong. We can monitor networks with 150,000 nodes with a single virtual machine. The reason we can do that is that unlike other solutions, we're coded in C and C++. Our database is compiled directly into the application for performance reasons. So the database we use is SQLite. That way it's no fuss, no muss, no licensing issues, and it's incredibly fast because it's compiled directly into the application. There's no ODBC layer. So there's a lot of performance things we've done on the back end. And the design intent is you shouldn't have to go out and say, gee, I've got 7 collectors out there that each have their own separate database. We have to license. All of a sudden, you've got a headache regarding your monitoring solution. And it's like, no, it's supposed to reduce headaches, not add headaches.
How frequently does it actually pull the network devices?
So by default, and we kind of recommend this, is every 5 minutes. We're going to get interface information, utilization information, device CPU, all those error counters, CDP, LLDP, QoS, all of that information every 5 minutes. And in one sense, people think, gee, isn't that going to overload the network? And I'll say no, because our software was designed by network folks and not designed by programmers who had the lead in it, is that we do what's called a slow pull. Our slow pull figures we have 5 minutes to collect all this information off this one device. So we can take a very slow path to getting that done. Meaning if you have a device that has 48 interfaces, okay, you've got 5 minutes to collect 48 interfaces worth of information. Do it in a slow and methodical fashion. And so the trick here is that if you do proper packet design, SNMP packet design, where you're not just sending out a flurry of SNMP packets like a lot of other products do, but you send out thoughtfully designed SNMP packets that says, get us these 18 OIDs, and we can make a determination off of the information we get back as to whether we need more information or not. And that slow pull mechanism with only one thread opened to that device means there's only one packet in transit to a device at any point in time, meaning we can have a 64K link to a device and we're not going to end up occupying a bunch of bandwidth on that 64K link. We're also not going to end up causing a CPU spike to that device, yet we're going to get far more information off of that device than any other monitoring solution. So I apologize for the long-winded answer, but I figured it needed some technical depth to describe. Does that answer your question?
It does. That's great. Thanks, Tim.
Do you also pull like the rib tables and some of these larger tables that could get fairly large and could potentially even exceed a long polling cycle?
So yes, so those sorts of the routing tables are queried. We will interrogate the device to say, how large is your routing table and can we get this in a 5-minute period? If we can't get it in a 5-minute period, we're not going to bother overloading the device and saying, hey, let's try and get this twice. So based upon the device's speed and performance and the size of the table, we might only query that once every 10 minutes.
Okay, so, and does the operator get like notification? It's like, this particular device is a little out of spec for this, and just be aware that the refresh cycle is different.
Yeah. So we will end up sending a pull failure notice that says, hey, we didn't get this information within a 5-minute period. We're going to make an adjustment. That way there's awareness of what's going on, but it still is that we're still going to get the data. And that's part of the trick that we figured is SNMP is so broken out there. There's so many MIBs that a device will say, hey, we support this MIB. And the MIB might say, gee, we've got 100 different OIDs in that MIB, but only 5 OIDs are actually supported by the device. Or it might have a whole bunch of different OIDs, and you have to say, well, query this one. that's not getting back good data. Query this one, that's not giving us good data. Oh, that's the one that they actually put the good data in. So all of that is gone. We're going to go talk to the device and say, oh, you're a Cisco device. You're a Nexus device? Okay, you probably have these defects, but you support these variables. So we're going to automatically go collect that information based upon how the device presents itself to us, so that we're going to be able to say, here's what this device is trying to tell you based upon the information that it's sharing with us. And so that's really all automated, so that you're not spending your time digging through MIBs and OIDs and trying to find out where can I get good data off this box.
Hey, Tim, what does this run on? Is this on Windows, Linux, all the above?
So this runs on Windows. So Windows Virtual Machine, typically a small virtual machine. So you don't need to have gobs of memory. You don't need to have gobs of disk. And you don't need to have a pile of CPU sitting around. In fact, if your network is 10,000 nodes or less, a single virtual CPU, 4 gigs of RAM, and 10 gigs of disk space should be enough.
What do you define as a node? Is that like an interface? Is that a network device?
An interface, a network port.
Okay, so my next question would be along the terms of scalability. Like, how many network devices can we scale to? Like tens of thousands? Is that within the realm of reason?
So devices are not our limitation. It's really number of interfaces. So 150,000 interfaces on a single virtual machine is kind of where we say that's about the limitation right now.
How hard, I know this is going to be a hard question to answer, but let's say that there's something I want to collect in my network that's important to me, like BGP state or interface transceiver DOM metrics, or something. What does it take to get a feature like that put into the product from a start to finish? And I understand that it all depends on what it is you're trying to collect and what you're trying to do with it. But if somebody said, gosh, we run for example, a multicast enabled network, and we want to see when entities join and leave multicast trees, and we want to see the shape of those multicast trees kind of in near real time. So very similar to what you did with the call path tracing and the call simulator, to do something with multicast, for example. That kind of ask by a customer. What does it take to get something like that done?
So here's actually our take on this is, if you look at a lot of other monitoring software packages, what they'll do is they'll install within the first hour and then say, great, what do you want to monitor? And you're like, well, there's hundreds or thousands of things I want to monitor. So it tends to be a manual setup to get that visibility. And you either run out of licensing or run out of time before you get adequate visibility. What we figure is, if we automatically will show you 90 to 95% of your network and say, here's everything that any seasoned expert would want to know about their network, then we'll give you a MIB browser and say, here, go get the custom stats that you want beyond this. If you want light levels, transmit levels, any of that sort of stuff, it's effectively 5 minutes to go through the MIB browser and say, here are the additional stats I want on this interface. And by the way, I want to template this so that I can copy and paste this to say, do this for all 20 of my switches. So that once you create that template, it's very quick to say, let's get this light level on all of these switches that have that OID, so that we know what's going on, and also alerts. So it's that the visibility is, you're 90% of the way there within the first hour of deployment. And then you want to add certain little customizations, easy to do.
Yeah, but I don't think so. I mean, because that wouldn't be your answer for the call tracer feature. I mean, you built the call tracer feature so that you can say, here's an IP address, trace it through my network, show me every hop along the way to indicate whether or not this is a bad call. And if you didn't have that feature, and I asked that same exact question for that feature, I don't think that would have been your answer, right? Because you built call tracer.
Sorry, I apologize. So I was talking about custom adding certain OIDs and MIBs and that sort of stuff. So you're talking about complete new feature design. And in one sense, I think one of our other delegates here, they saw our product just 2 years ago, maybe even a year and a half ago. And I'll ask you and say, have you seen us add a ton of features in that year and a half? Because we've been pushing the pedal to the metal regarding adding a ton of new features. And that's really kind of our trick, is that we figure we want new ways to solve problems. And we'll work with customers to say, if you have a need, and this is something that definitely adds value to the product, we can add things within 6 months, within a year. And it's that our dynamic development is just allows us to be a lot faster at getting those sort of problems solved.
I'm gonna tack on one more question real quick, just back to the topic of operating systems that you run on. You mentioned Windows only. Does that apply to like that call simulator and Wi-Fi testing deal that you showed off as well?
So, okay, so the module for doing call simulation and remote view, that is Windows. We do have a solution that supports really any browser. So we have WebRTC testing as well. So if you have a cell phone, you have a Mac, anything that runs a modern browser, it will use WebRTC to test to say, are we seeing latency, jitter, packet loss, low frame rate, all of that. But we're using the browser's hooks to be able to determine what sort of quality we're getting.